Hello everybody. In this video I'm going to give a little supplemental instruction for completing the Labflow report for this week, the Entropy of Borax Dissolution. The first thing you're going to see is a bunch of pictures indicating there's a burette and there's thermometers. Do keep in mind that the burette starts with the lower numbers at the top and then goes up as you go down. And the thermometer is the opposite. The lower numbers are on the bottom and they go up as you go up. You should always keep that in mind. Also, that you should be able to estimate between these graduations. So for instance, this mark right here would be 59 degrees, but I entered this value as 59.1 because I said, well, it's just a little bit above that mark there. You're going to go through and do quite a few of these. And then you're going to be presented with two tables that have the summary of our data. And what we've done here is we've changed the temperature each time drawing out a 5 milliliter sample of the borax and then titrating it. After that, we get to this table. This is where we're actually going to fill in our data. And it's pretty straightforward. The first thing that they're going to want you to calculate is the volume of hydrochloric acid used. And that's just going to be the final minus the initial. You'll enter that value in here. After that, this was a titration, so we do have a consistent concentration of HCl throughout here. And what they're asking us is what is the moles of HCl used. In order to get that value, we're going to need to take the concentration times the volume, but we need to pay attention to our units here. Okay, this concentration is in molarity or moles per liter, and we have our volume up here in milliliters. So you'll have to convert this value to liters, multiply it by this in order to get the moles of HCl used. After that, we're being asked for the moles of the borate present. That means that we need to handle our stoichiometry. If we come over to the PDF, we can see that this is our reaction right here, and that we're going to consume 2 moles of acid for every 1 mole of the borate. Basically, that's going to translate into the fact that the moles of borate are going to be half the moles of HCl that we used. After that, we have the volume. The volume's always the same here. We're basically drawing out, well, it's close to the same at least. We're drawing out a certain amount. And then we have the concentration of borate. So what we're going to do is we're going to take the moles, we're going to divide it by the volume in liters. We have to make another conversion here to get the molarity of the borate. Once we have that, we're being asked for the KSP. If we go back to the PDF here, we can see that we can derive a clever expression for the KSP in this case. It's going to be 4 times the concentration of borate cubed. So you'll calculate that. You'll enter in these KSP values for each of the runs here. And then you'll take the natural log of that value, the natural log of the KSP, and you'll enter those values in here. Here we have the temperatures. These are, again, from our readings that we took with the pictures. And what we want to get is 1 over the temperature. But we also want that in Kelvin. Okay, so again, we have to pay attention to our units here. We'll need to convert this to Kelvin and then take the reciprocal of it in order to enter these values in here. After that, we're going to make a plot. I'm not going to get too much into how to make the plots. We've done that quite a bit this term and in previous terms. Basically, what we're going to do is we're going to take this equation and we're going to linearize it. So we're going to have y is going to be ln k that you calculated up here, and x is going to be 1 over t, which we calculated here. That means that the slope of this line is going to be negative the change in enthalpy over the R gas constant. Okay, we'll put the slope into here after we've made our plot in Excel, and then we're going to be asked for delta H. Some people struggle with this a little bit, but if this slope is delta H divided by negative R, we need to multiply by negative r, take the slope, multiply by negative r, and we'll be able to get the enthalpy. We're going to do the exact same thing when it comes to the entropy. We're going to enter in the y-intercept, which we know to be delta S over r. And then to get delta S, we need to multiply that intercept by r. After that, you're going to upload your Excel file. You're going to upload any of your calculations and stuff. And you're going to answer a few questions down here, a few post-lab questions. And then finally upload all of your work here. And that's going to be it.